Welcome to the Engineering Restoration Project. Today, we begin with an old washing machine motor. This is a standard single-phase electromagnetic induction motor. On the outside, it is quite rusty and degraded. Severely. I will place it on the workbench to dissect it. The goal is to turn it into a generator of 220 volts alternating current. First, the drive pulley, which has this V-groove, is no longer needed. I will mark the position on the shaft core to cut it. Using a high-speed angle grinder with an alloy cutting disc, I cut directly into the metal layer of the pulley, very carefully. After cutting off the piece, I use needle nose pliers to break off the excess metal. The original steel shaft head is completely exposed. Next is removing the outer casing. Use a hand drill to drill out the rivets, releasing the clamping force holding the steel plates of the stator. After many years of operation, the mechanical parts are tightly bound by oxidation. Use a screwdriver and pliers to loosen the locking pins. The removal process must be even at all corners. The zinc aluminum alloy frame is very prone to cracking if subjected to excessive off-center prying force. Pull out the 4 long positioning bolts one by one that pass through the motor body. The main load-bearing structure of the device has been released. Moving on to the connector plug for the coils. Use a screwdriver to pry the plastic tabs. Carefully detach it without scratching the copper wire. Use your hands to separate the aluminum flange cover. Inside, the structure is exposed, the stator with the run winding, and the start winding perfectly intact. Slowly pull the squirrel cage rotor block out of the stator's magnetic core. The rusted surface of the electrical steel severely reduces the magnetic flux efficiency. Spray WD-40 penetrating and lubricating fluid directly to loosen dirt and rust adhering around the old bearing housing. Clamp the aluminum flange cover firmly in the vise for leverage. Use a socket to knock the broken bearing out. This bearing will be replaced with a new one. Use a wrench to remove the retaining washer on the rotor shaft. Then, firmly clamp the rotor block horizontally on the vise surface. I attach a steel wire brush to the cordless drill. Proceed to grind and polish the electrical steel core surface of the rotor. This oxidation layer must be completely removed to ensure the magnetic flux passing through the air gap in the motor is optimal. Clean the shaft and apply a few drops of lubricating oil. Insert the new bearing and apply even pressure to press it into the correct retaining slot. For the zinc aluminum alloy flange covers, I continue to use the steel wire brush to scrub away built-up dirt and rust. This process restores the aesthetic appearance and enhances the capability of heat dissipation for the motor casing when operating under heavy load. Finally, spray a professional cleaning solution and use a soft cloth to wipe every nook and cranny clean, especially the bearing mounting position. Prepare a pair of new industrial standard bearings. These are the components that determine the smoothness of the shaft. Use a wooden stick to evenly apply a layer of red heat-resistant grease. This grease fills the gaps in the flange cover. Place the bearing in position. Use a cylindrical metal rod and a hammer to gently tap the bearing down into place. Reassemble the rotor block with the flange cover. The steel shaft presses tightly into the inner ring of the bearing smoothly. Proceed to clean the stator block using a steel wire brush. The rust layer outside the magnetic core is completely ground away. Spray maintenance chemical and wipe clean with a soft cloth. Ensure there is no residual dirt that degrades the magnetic field. Returning to the copper wire ends of the stator coil, I use pliers to cut off the unnecessary old plastic plug connector. Use a multimeter in resistance measurement mode. Connect the probes to accurately identify the run winding and start winding. Push the entire rotor block and flange cover into the stator. Align it precisely so the magnetic flux gap is uniform. Close the remaining flange cover and tighten the 4 retaining bolts around it using a socket wrench to secure the entire structure. Checking by hand shows the shaft rotates very smoothly. This proves the bearing and shaft are perfectly concentric. Strip the insulation layer from the electromagnetic wires. Prepare a red electrical wire with a large cross-section copper core. Use a soldering iron to melt solder and secure the joint. This is the output line for the alternating current that will be generated. Thread a heat shrink tube over the solder joint. Use a lighter to heat it. The shrink tube will contract and seal the joint for insulation. Mount a toothed aluminum pulley onto the end of the rotor shaft. Tighten the hex set screw to lock the pulley in place. Next is a small 4-stroke gasoline engine that will act as the power source to drive our generator. Prepare a flat piece of plywood and use a power drill to securely fasten 4 omnidirectional casters to the 4 corners to make a base. 1. Place the DIY generator on the wooden base. Attach a steel bracket, shaped like an N, and arc weld it directly to the motor casing. 2. Put the gasoline engine into position. Loop the toothed drive belt over the 2 pulleys and adjust the distance to create tension. 3. After aligning the belt, use wood screws to secure them. Both the drive engine and the generator are now firmly connected. Disassemble a standard universal power strip, then cut and strip the 2 electrical wire ends from the generator. First, connect these 2 wires to the copper bars inside the power strip. Tighten the screws, close the cover, and mount the strip on the base. The system is now complete. Pull start the 4-stroke gasoline engine. The drive belt will spin the generator shaft at high speed. Use a 220 volts angle grinder to test the load. Plug it into the power socket. When you flip the switch, the grinder starts up powerfully right away. Electromagnetic induction from the steel cores, residual magnetism, has turned the old motor into a true 220 volts power generator.